So this says here that functions of the form y equals ab to the x, or exponential functions, because that's what we just talked about, and where a is greater than 0 and b is greater than 0 are called exponential growth functions. And they will all have the same shape as the graphic example 1. So exponential growth functions will always look something similar to that. They'll be going up. They're growing. Functions of the form y equals ab to the x, where a is greater than 0 and b is between 0 and 1. Notice b has to be positive, but b is between 0 and 1, so it's going to be a fraction or a decimal, are called exponential decay functions. They all have the same general shape, which is kind of the opposite. They start high and go low. Exponential decay functions go down, growth functions go up. Growth functions grow, decay functions, you can almost think they die or decay away. So this one on the left is growth. This one on the right is decay. So let's look at an example. Here would be an example where we have decay, because notice, b is between 0 and 1. We said as long as b is between 0 and 1, it's going to be an exponential decay function. So we're going to find the y-intercept, state the domain and range again. So for my y-intercept, I just have to plug in 0 for x. I get y equals 1/3 raised to the 0. We know anything raised to the 0 is just 1, so I get y equals 1. So my y-intercept is 0, 1. Then I just need to find a couple more points. I'm going to find where x equals 1, so I'm going to plug in 1 for x. And then I'm also going to plug in 2 for x. For 1 for x, I just get y equals 1/3, so my point would be 1, 1/3. For y equals 1/3 raised to the second power, remember you kind of distribute this exponent to each part, so I get y over 1 squared, which is 1, over 3 squared, which is 9, so I get y equals 1/9. So I get the point 2, 1/9. So now I've got 3 points, I can go ahead and plot them. I've got 0, 1. Then I've got 1, 1/3, 2, 1/9. And you can see why this is going to end up being a decay function. Because it starts out high, and obviously we haven't gone negative, but it would start from up here, and it would come down, and then it just keeps getting closer and closer and closer to 0 while never crossing the x-axis. And here's something that is actually a little interesting. When we go to find the domain and the range of a decay function, the domain and the range will actually be exactly the same as a growth function. Because notice, even though it starts high and goes low, it's still going from negative infinity to infinity for x. So my domain is the same. Remember, domain is the numbers you can put in for x. So I can go anywhere on the x-axis. And it's the same thing as we had in the first example for where I can go on the y-axis, or what the range is. I can go anywhere I want as long as I'm positive, but I never go below the x-axis. So my range is still going to go from 0 up to infinity. So notice this is exactly the same as what we had in example 1. So we know now that growth and decay functions will always have the same domain and the same range. Domain will go from negative infinity to infinity, range will go from 0 to infinity.